Welcome to YQ Academy, SQL Interview Questions and Answers. 1. What are the properties of relational tables? 1. Rows. Table consists of rows, also known as records or tuples. Each row represents a single entity or data record in the table and contains data values for each column. 2. Columns. Tables are composed of columns, also known as attributes or fields. Each column represents a specific piece of data or characteristic associated with the entities represented by the table. Columns have names and data types that define the kind of data they can store. 3. Uniqueness. Each row in a table is uniquely identified by a primary key. The primary key ensures that no two rows in the table have the same combination of values for the key columns. 4. Relationships. Tables can be related to each other through primary key foreign key relationships. These relationships establish connections between tables based on common attributes, enabling data retrieval and manipulation across related tables. 5. Integrity constraints. Tables can have integrity constraints, such as primary key, unique, and foreign key constraints, to enforce data integrity rules and maintain data consistency. These constraints define limitations on the data values that can be inserted, updated, or deleted in the table. 6. Normalization. Relational tables are typically designed following normalization principles to eliminate data redundancy and ensure data integrity. Normalization involves organizing data into multiple tables with minimal data duplication and logical relationships between them. 7. Relational algebra. Relational tables support relational algebra operations such as selection, projection, join, and union, which allow for querying and manipulating data in various ways. 8. Indexes. Tables can have indexes on one or more columns to improve query performance. Indexes provide a quick lookup mechanism, allowing faster data retrieval based on the indexed columns. 9. Data independence. Relational tables promote data independence by separating the logical structure of the data table schema from its physical storage details. This allows for easier modification and maintenance of the database without affecting the applications that use the data. 2. What is normalization? Normalization is the process of organizing data in a database to eliminate redundancy and improve data integrity and efficiency. It is a set of rules and guidelines that ensure the database is structured in a logical and optimal manner. 3. What are the main objectives of normalization? 1. Eliminate data redundancy. Redundant data is data that is unnecessarily duplicated in multiple places within a database. Normalization aims to eliminate this redundancy by breaking down data into smaller, more atomic pieces and storing each piece in only one place. This reduces storage space requirements and avoids the risk of inconsistencies or anomalies when updating or deleting data. 2. Maintain data integrity. Normalization helps maintain data integrity by enforcing rules and constraints that prevent data inconsistencies. By organizing data into separate tables based on their logical relationships, it becomes easier to enforce referential integrity, ensure data consistency, and minimize data anomalies. 3. Increase data consistency. Normalization reduces the chances of data inconsistencies and anomalies by enforcing data consistency rules. With well-defined relationships and constraints, the database can ensure that data remains accurate and reliable across tables. 4. Improve query performance. Normalization can improve query performance by reducing the number of tables that need to be accessed for a given query. By breaking down data into smaller, more specialized tables, queries can be optimized to retrieve only the necessary data. 4. What is de-normalization? De-normalization is the process of intentionally introducing redundancy into a database design by relaxing the normal forms of normalization. It involves combining or duplicating data from multiple tables into a single table to improve query performance, simplify data retrieval, or meet specific application requirements. 5. What are the reasons for denormalization? 1. Improved query performance. De-normalization can eliminate the need for complex joins across multiple tables, reducing the number of table accesses and improving query response time. By combining related data into a single table, the database can retrieve the required information more efficiently. 2. Simplified data retrieval. De-normalization can make data retrieval simpler by reducing the number of tables that need to be accessed. It can be beneficial in scenarios where frequent and complex joins are not practical or result in performance issues. 3. Reduce data complexity. De-normalization can simplify the database structure by reducing the number of tables and relationships. This can make the database design and maintenance more straightforward, especially in cases where the data model is highly complex or evolving. 4. Support for specific application requirements. In some cases, certain applications may require data to be stored in a specific denormalized format to meet specific business rules, reporting needs, or integration requirements with other systems. 6. What is nested trigger? A nested trigger, also known as a recursive trigger, is a trigger in a database system that is fired as a result of another trigger being executed. In other words, a nested trigger occurs when a trigger, during its execution, performs an action that causes another trigger to fire. Nested triggers can occur in database systems that allow trigger cascading, which means that triggers can be defined to execute additional actions that may invoke other triggers. When a trigger is fired, it can perform an action that causes another trigger on the same table or related tables to be executed. 7. What is a linked server? A linked server in SQL Server is a feature that enables you to connect and access data from another database server or data source. It allows you to establish a connection between your local SQL Server instance and a remote server, which can be another SQL Server instance, Oracle database, MySQL database, Excel file, or any other data source that has an LADB or ODBC provider. By setting up a linked server, you can execute queries, perform data manipulation operations, and even join data between the local and remote servers as if they were part of the same database. This enables you to retrieve and update data across different platforms and systems without the need for complex data transfer or integration processes. The linked server feature provides a way to access and manage data from various sources using the familiar SQL Server interface. It allows you to execute distributed queries, fetch remote data, and even perform distributed transactions in some cases. 8. What is collation? Collation in SQL Server refers to the rules and settings that determine how string data is sorted and compared. It defines the order in which characters are sorted and the rules for comparing strings, taking into account factors such as character sets, character case sensitivity, accent sensitivity, and linguistic conventions. In SQL Server, collation settings are specified at different levels. 1. Server-level collation. This is the default collation for the entire SQL Server instance. It is specified during installation and applies to all databases on the server unless overridden at the database or column level. 2. Database-level collation. Each database in SQL Server can have its own collation, which can be different from the server-level collation. The database-level collation applies to all string data within that specific database. 3. Column-level collation. Collation can also be specified at the column level, allowing you to override the collation settings defined at the server or database level for specific columns. This is the end of our SQL interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.